Okay, today we're going to talk about fatty acid synthesis. And in order to talk about fatty acid synthesis, we need to talk about fatty acid synthase. So, fatty acid synthase is an enzyme that's present, uh, in the cytoplasm that synthesizes fatty acids, and it synthesizes fatty acids 2 carbons at a time. And you won't be surprised, hopefully, if the 2 carbons that we use to synthesize fatty acids come from our acetyl CoA. These are the 2 carbons we used or that we generated when we broke down fatty acids, and they're the 2 carbons we're going to use to build them up. Okay, now there is an issue here in terms of location, right? The acetyl CoA we're used to thinking about as mitochondrial in the Krebs cycle. Yet fatty acid synthase is going to act in the cytoplasm. And so we're going to have to get these mitochondrial acetyl-CoAs to the cytoplasm so that this enzyme can work on them. And so there's a shuttle. And the shuttle you actually kind of know already if you remember the Krebs cycle, right? Oxaloacetate. You might remember that one of the first steps catalyzed by citrate synthase in the Krebs cycle is oxaloacetate plus acetyl-CoA goes to citrate. That's not a very good citrate, but that's citrate. It turns out that this reaction can go backwards and forwards, and really these mitochondrial citrate can be shuttled through the citrate shuttle across the mitochondrial membrane, and when it reaches the cytoplasm, it can go backwards to break apart into oxaloacetate and acetyl-CoA. And that oxaloacetate can come back into the mitochondria. So if we think of this as mitochondrial, this is cytoplasmic, really it's the citrate shuttle is going to take those 2 carbons into the cytoplasm, break them apart to form acetyl-CoA, and allow acetyl-CoA to be accessed in the cytoplasm by fatty acid synthase. So we call that the citrate shuttle. Okay, but let's assume that these acetyl-CoAs are in the cytoplasm and we can use them with fatty acid synthase. Now, it turns out what happens is that acetyl-CoA is not directly used at the beginning of this process. We have to invest a little bit of energy to use it. So we're going to take a vitamin called biotin that is bound to a carbon dioxide, CO2 minus, and we can join these two things together to form really the basis for fatty acid synthesis, a molecule of malonyl CoA. And malonyl CoA is really just our acetyl-CoA with a carbon dioxide stuck on it. Okay, so here it is. We would call this malonyl CoA. And the investment of energy in here is that every time we sort of charge up one of these 2 carbon pieces with the addition of that carbon dioxide, it costs us an ATP. Okay. Now, as fatty acid synthase grabs onto malonyl CoA, as it adds 2 carbon pieces, this carbon dioxide gets jettisoned off. So let's look at the basic framework for how fatty acid synthase builds a fatty acid, and then we'll come back and we'll talk about the reactions involved in converting these 2 carbon acetyl groups into a long chain fatty acid. And you'll see that the reactions are pretty much the opposite of the reactions we saw when we were breaking down fatty acids. But let's look at this animation. Okay, let's see if I can do this. This will probably work. Okay, so we've got fatty acid synthase here, this big enzyme, and it really has two binding pockets on it. And one of them binds to the malonyl group. I've split that into two colors here, really the 2-carbon acetyl group plus that carbon dioxide group at the other end of it. And then we've got the acetyl group here. Okay, so what happens is that fatty acid synthase binds to, it's charged up 2-carbon piece, charged up with the carbon dioxide, and it has some growing chain over here. And what happens is that this, whatever is on this first binding pocket on the left here is going to move over and bind to the 2-carbon piece on the right side. I'm spitting out that carbon dioxide. Okay. Then some reactions occur, really reduction reactions that are going to take that carbonyl group that was on this acetyl and reduce it like crazy. And then the growing carbon chain on the fatty acid synthase moves over to the other binding pocket, like this. Okay. A new malonyl group is bound, and a transfer occurs. So the chain keeps growing by 2 carbons, spitting out that carbon dioxide one by one. The next round, this fatty acid synthase would move this growing chain over to the left position, bind another malonyl, and then shift it over to make a 8-carbon chain. Okay, so in essence, that's how fatty acid synthesis works. Now, in the next video, we're going to talk about the specific reactions that are necessary, really just to reduce that 2-carbon piece that we keep putting on there in order to turn those acetyl groups into just alkanes that are part of a fatty acid.